right, everybody. Welcome to Building a REST API with NestJS and Prisma workshop. My name is Marc, and I'm your host for today's workshop. I will be sharing my screen just in a minute. We are just waiting for a few more people to join the workshop, and then we are ready to start. Just hang in there. Thank you. The all black Prisma t-shirt just arrived last week, and I got also some other swag, like some nice stickers from the Prisma team. Hey, to India, Nihal. I guess, Arcadio, you might have to ask Prisma if they can send you a t-shirt as well. Or they have a swag store, probably. Just one more minute, and then I think we will be starting this workshop. I am already going to, just one moment. I'm going to already share my screen, so we can just get started. Sharing screen. All right. Just one more second. I want to see if I can find the Q&A section in the chat during the screen, during sharing my screen. Chat is here, so I will just pull it over to my side. And Q&A section as well. Awesome. Do you see anything? Do you see me sharing my screen? Do you see this Notion document? Perfect. All right. Then I think we're going to start now. All right, I will just pull this over here as well. All right, again, welcome everybody to Building a REST API with NestJS and Prisma workshop. My name is Marc. I'm your host for today's workshop. I'm sharing my screen to show you the outline of this workshop in the Notion document. This is a beginner-friendly workshop, and there are only a few prerequisites required. First, you will need a Node and also the Nest CLI installed on your machine. Basic experience is Nest.js is recommended, but not required for this workshop. I will copy over this link to the Notion document, and I will drop it into the chat so you can open it up and see all the information for this workshop. Here you go. Here's the link. Let me know if you can see it in the chat. All right. Perfect. Nice. All right. So what we will do actually today in this workshop, it is actually a hands-on workshop. So I will first show you the tasks, and then you have the time to do the task on your own. We are implementing a REST API with NestJS and Prisma. We are going to set up Prisma with a SQLite database and integrate Prisma with the NestJS architecture in lesson 1. In the second lesson, we're going to implement CRUD endpoints for the Nest API. We are also going to handle errors of Prisma Client with Nest.js filters in lesson 3. And we're also covering cursor-based pagination, which is quite useful for larger data sets, and finishing up with authentication in lesson 5. Here's a short agenda for today's workshop. As you can see, each lesson has a part host walkthrough as I walk you through the workshop of the lesson and the tasks, and then you will have time to actually practice them on your own computer. All right, a little bit about me. I'm a freelance full stack developer and open sourcer from Germany, building apps for the web and mobile. I write about my favorite tech stack on Notiz, including Angular, Nest.js, and Prisma with buddy Gary Großgarten. And in my free time, I like to stand-up paddle and inline skate. You might also know me from last year's Prisma Day. I gave a lightning talk about Nest.js and Prisma as well. If you like, you can get in touch with me on Twitter, on GitHub, also on Notiz, or in the Prisma Select channel. A little bit about Zoom. If you'd like me to answer any questions during the workshop, just drop them into the Q&A section. I won't have the whole workshop an eye on the chat, and it's much easier to find the answer in the Q&A section. Also, the workshop will be recorded and will be later uploaded to Prisma's YouTube channel. There's also a feature which is called Raise Your Hand. We can use that for doing quick polls and maybe asking if everyone is finished with their tasks. So if you like, you can just quickly try out Raise Your Hand. And I can, yep, I see 2, 3, a few more raising their hands. So I guess that's working. Perfect. Nice. All right. So that's basically it for the layout of the workshop. And we are driving right into the first, not lesson, but recap about Nest.js. Just a brief introduction. Nest is a framework for building server-side applications with Node.js and by default Express as a server. It allows you to build APIs like REST and GraphQL, and we will be focusing on REST today. Nest's architecture is heavily inspired by Angular and contains of a few building blocks such as modules for organizing and grouping related features together, controllers for defining REST endpoints, and resolvers are the equivalent to controllers just for a GraphQL API. And finally, the services, which are really important for implementing and isolating your business logic. There are a few more files involved in a Nest application, and we will see a few of them during our workshop. All right, I will just jump into the first lesson. If you have any questions, just write it in and we will get it sorted out. So I will just move it over. Oh, sorry, quickly here. Get VS Code and ready here. All right. First lesson is to set up our Prisma and integrate it into Nest.js. I prepared a starter project on GitHub. You can find it on GitHub with the link, and there are a few instructions. You have to clone it, you have to install the dependencies, and if necessary, if you haven't already, installed the Nest CLI as well. I've already installed, cloned the project here, as you can see. Just want to walk through the project quickly. it is basically generated by the Nest CLI. We have one thing added to this project, and that is the Swagger API. It's added to the main TS configuration file. And also, as you can see here, if you expand Swagger, the dependencies for Swagger have been added as well to the project. So everything works already out of the box for Swagger, and we can test it out when we start the application in watch mode, for example. If I go to localhost 3000 API, we have the Swagger API. Cool. And one more thing, I added products. Prepared some products for the REST API, so we can see the database in this lesson. And we are building a stand-up paddle online shop. And I've got a few example and dummy products in here. All right, this is it for the setup. There are branches in this project you can check out later if you want to see the result. But otherwise, we will be implementing the lesson step by step. Just a reminder, it might be probably the best that I first do the task. You watch me do all the tasks, and then you have the time to do them by yourself, and of course ask some questions too. All right, first step is to actually integrate Prisma. We don't have Prisma yet integrated. There's no dependency for Prisma in this project. So I'm going to start adding the Prisma CLI as a dev dependency to this project. When that's done, I can initialize Prisma in this project, and this will give me the Prisma schema. Actually, today, Prisma released the latest version 2.26, and we can actually specify that we want to use the data source SQLite, and then we can actually skip some of the tasks here to just change, because the default is usually Postgres, and we're just going for it using a new feature, because as we can see here, the latest version has also been installed. So I'm just going to initialize Prisma now. We're getting this Prisma directory containing the Prisma schema and also a .env file. We are pointing the SQLite database to a dev.db file inside the Prisma directory. And this is already the first step. No, not actually. We need to install the Prisma client as well. I forgot about that. Someone raised their hand. Just if you have any questions, just drop it into the Q&A section. I will be looking into the next task. This is, I've prepared a product model. Prisma schema is holding all the Prisma models which are representing the database tables. And we are just going to copy over the product model into the Prisma schema. The product model has a few fields, the ID as a primary key, created and updated as a timestamp, name as a string, description is optional, price as decimal, a product SKU is unique, and I'm using this for identifying like variation of different color and sizes. And I just wanted to have a unique value in here. And also there's a published field which is by default false. So right now we don't have any SQLite database, so we can just run a command from the Prisma CLI, which is the Prisma migrate dev command, npx Prisma migrate dev. Garrett, do you have a question? Just drop it in to the Q&A section. Do I need to increase my font size? Is it better if I increase it a little bit? Okay, cool. That's fine. Garrett, any questions? Just drop them into the Q&A section. All right, back to the migration command. We can run this command to actually create a migrations directory and also the SQLite database for us. We can specify a name with -- name and, for example, provide a name like init or product. I will go for product here. And as you can see here, I added into this Notion document some solutions. Anytime when you're later doing the task and you can't remember, you can always look into the solution, how it will look like. Or you can, of course, compare your result with the solution as well. And here are the terminal commands as well. Perfect. The database seems to be created. I have a dev.db file in the Prisma directory and as well a migrations directory. This is really important to actually add the migrations to source control. So other people on your team can use those migrations, and they are also used for deploying to different environments. DevDB has been added to gitignore, so you won't add the developer SQLite database into source control. All right. We want to now seed the database with the provided products here. To do so, we can add a small script seed.ts into Prisma. Prisma actually has support for different files which is used to seed the database, seed.ts, seed.js, and some other configurations. I'm just going for seed.ts. And this is basically the task. We are going to import and instantiate the Prisma client. So I'm going to do this right now. Prisma, new Prisma client. And it's imported right away. And then I can also next import my products seed from the root folder, products from products. Cool. Now we are going to create a main function which is asynchronous, so we can actually await the database, the create performance of Prisma client. So function main, and I'm going to loop over those products. Sorry for that. Let product of products, and here we're going to await Prisma, and we have a product. This is type safe, auto generated by the Prisma client. I forgot to add the instantiation brackets here. And we can say create, and we are just passing the product into as the data. Not Prisma, product. All right. Finally, we can just call the main function, main. And in case there are any errors, we can just catch the errors, probably log them. So maybe we know why there's any errors. Maybe because of the product SKU, because it's a unique field. And then it's common to say process.exit with a #1 error code. And finally, we can also disconnect Prisma from the database. And we do this asynchronous as well. And we are going to await Prisma.disconnect. Cool. So just formatted this. And as you can see here, there's also a similar or the same solution to the seed.ts file. So what we are going to do now is we are using the Prisma CLI preview command to actually seed the database npx prisma db seed. And we have to specify preview feature because currently it's still in preview. And this will execute our small seed script. And if it's successful, we will see your database has been seeded output. To just make sure and verify if the database actually has been seeded, we can open Prisma Studio and look into the database. So let's open Studio, run it, and it's actually opening Prisma Studio directly in the browser. And here we go. We have 15 products. Some of them are published, some of them are unpublished. And yeah, a couple of files are in there. Awesome. Now, as we have the database in place, we have this model in place, we can go ahead and integrate Nest, Prisma Client into Nest architecture. To do that, we are going to use a model and a service. We can use the Nest CLI to generate the module for us. So Nest generate module, and we call both the service and the module the same. We call it Prisma. I just run it here. And there's also a shorthand version. So for example, Nest generate Prisma. So we can have a look what has been generated. The module will be used to actually create a singleton instance of the Prisma service. And it also allows to share the Prisma service instance between other modules. And also the Prisma service takes care later of instantiating the Prisma client. And even it could allow us to explicitly start a database connection. So now we have to, in order to actually export or use the Prisma server somewhere else, you have to add it to the export list of the Prisma module. So we're going to add it here. And we can mark Prisma module as globally with the global decorator. So we won't have to import Prisma module into each and every module, as this might be tedious and even forgotten at some point. But probably we will use database access eventually throughout the whole application. The Prisma module, as you can see, is imported to the root module, the app module, and we can now use the Prisma service everywhere in our application. Here's also, again, a solution. This is for dependency injection. So the next step is actually to go into the Prisma service, and it's simple as extends Prisma client. And this is already what we have to do for using or extending the Prisma service with Prisma client. We can even pass some options to Prisma client. We can add a constructor here, add super, and now we have the Prisma client options here. For example, we can add a log level. We can set it to info, for example. Last task in this lesson, we are actually going to use Prisma service to build our first endpoint. So we're going to implement get products endpoint in the app controller. To do so, we have to add the Prisma service just created into the constructor. This will be added via dependency injection. And we can add Prisma service, not the client. We are going to create a new endpoint, get products. get products, and we can call it find published products, as we want to only fetch all published products from the database. So return. Now we can access Prisma, not throw, this dot Prisma dot product, and we can find many. Now we are returning all products, but we want to filter by published true fields. All right, let's start the Nest application, probably in watch mode. And then we can actually go to the Swagger API again, refresh when the server is ready. And now we have our first products endpoint. What we can do now is we can just call it and see if we are actually getting some information. Yes, we are retrieving our products from the database. Perfect. And one note, here are some logs added to the console. And this is because we added previously log level info to Prisma Client. And anytime the first call is done with Prisma Client, it will create the connection. And if I do it again, it will reuse a connection from the connection pool. And this is just to see some information about the events, what's happening and going inside inside Prisma Client. Nice. That's it for now. I can also even go onto localhost 3000/products. And as you can see here, also I have the endpoints or the response available. Cool. Now, this is actually it for my side for this lesson. So you now have around 5 to 10 minutes to go through the setup. So clone the project and set up Prisma and integrate it into Nest. I will be muting myself during that time and also turning off the video so you have some distraction-free time. And if you have any questions, just drop them into the Q&A section. All right, so I will be turning on everything again. I think most of you are ready. So I think it's best to continue. I hope others can follow still along. You can always go back to the lesson later as well. All right, jumping into the next lesson, REST API. And the goal of this lesson is to basically use the Prisma service we created the previous lesson and implement REST CRUD operations for our product model, and also define types using Swagger API. The setup is basically the same. We are going to use the same project, but we're going to change into the REST API branch so everyone is on the same page. So to do that, we're going to add all changes to staged, and then we are stashing them away so you can still go back to them later. And then we're going to check out the REST API. And basically, the Prisma service is here as well. We don't pass any options here, but that's fine. And the app controller, the products endpoint has been removed because we will implement it soon again in another controller. Yeah, so after checking out your REST API branch, we can start using the Nest CLI to generate us some files. So for REST endpoints to implement CRUD operations, we will need a controller, we will need a service, we will need a module, entity classes, and more and more. But wait, there's actually one command to do everything for you. So all boilerplate code can be generated for us. And this is done by running nest generate resource. Not like this, resource, like that. And then you have to specify a name. So we go with products. We are going to select REST API, and we are saying yes to generate CRUD entry points. And this will create a bunch of files for us, and we are going to look into them. So we get our products controller. We have a products module which are exporting the controller and defining the product service. The controller is actually calling for each endpoint already the service. And I think just, dummy data, but that's actually really useful because we can just implement and use the Prisma service to replace those dummy data. And I'm going to just start the API again. I'm still in watch mode and the database is still here. So we can just open up and we can see we already have our CRUD operations. We can create products, we can get all products, we can just get one product and so on. And what we notice here, we can have all endpoints under one default tag. And it's the easiest way to just go in here into the controller and add an API tags decorator and specify the name, for example, products. And after it's built, we have now a separate tags for all products endpoints. Nice. All right. So this was already one of the tasks. And now we can actually implement for each endpoint using the Prisma service. So we can get started with the get products endpoint. I'm going to jump into the product service find all. And first we need again the Prisma service. So I'm adding the Prisma service right into the constructor, Prisma service. And now I can just call Prisma and we want to find all products again. And again, we just want to have the published products for this endpoint where published true. And just to check out, we can run this command and yes, it returns the product data as it was done before in the previous lesson. Now we can continue implementing all other endpoints. This will be the task for now. And when we are done with that, we are going into the Swagger types, but I will implement the CRUD operations now, and then you will have maybe 5 minutes to do that as well. And then we have a look into the Swagger types. Right, so first, let's get into the next CRUD operation, get products by ID. So here we have the ID, we want to, this dot Prisma, and we want products and find unique because we want only one by ID, where ID is equal the ID. Now we have some complaints here. So here we have a number, but it's actually expecting a string. And this is because in the Prisma schema, we also defined the ID is supposed to be a string. Easy solution is to just change this to a string, then it's working. But let's have a look in the controller. And here it's actually the param is just passed to an integer, to a number. So we can just remove the plus sign and it will just work fine. We can also test it out, run find all products, and then just try it out here. And Swagger generates everything for us. We can add the parameters here. And as you can see here, we also have a response body for the first product. All right, let's have a look for the next endpoint. That's the post products endpoint. First, we will connect it to Prisma Client, to the CRUD to the type-safe operations. We use create, and then as we did in the seed file, we can say data is supposed to be create product DTO because it has been generated for us. Now we have some missing properties here. Name, price, and SKU are the required fields for a new product. And let's have a look into the product DTO, and it's empty. So basically, we just need to add those properties which we like to be able to add a new product with. So we use the properties name, description, price, SKU, and published. And we also want to make them available for Swagger, for the Swagger API. So we are going to add a name, and that's a string, a description that's optional, and a string, and not a B, it should be a P, string. Price, it's a number, because we defined it as a decimal. A SKU is also a string, and the published value, published, will be a Boolean. And also optional, because we can also create a product without a published, because by default, we can have a look here, by default it will be set to false. All right, if we refresh here, we don't have any informations about the schema because get product DTO is still not available for Swagger. So what we can do is we can use API property decorator to tell Swagger about this property. API property. And we can do the same for a couple of them. I just duplicate them and I give a little bit of spacing, so maybe it's even easier to see the properties here. So all right, let's go back, refresh, and we can even have a look at the bottom here. So now we have all properties available for Swagger API, but as we can see here, description and published have a star, which means they are required as well. We can go into the property and say required false. I just copy this for published. And because I'm in dev mode for the applications, always refreshing after it's saved. As we can see now, description and published is optional. And we can now try out our first post. I think I have one here available. Let's add some stand-up pedaling stickers. So we'll just add them here and execute. And as we can see here, we have a response, which is fine. And just to verify, we can also get all of our products again and scroll all the way to the bottom. They're not here yet because we, I think we say published or false, so they are not showing up in this endpoint. No worries, we will have a look in the next step, because we will at the end also create an additional endpoint to get all drafts. All right, this is it for the post. The patch is quite similar. We will go into the product service again. Here, this time, we are going to update a product using the ID, where ID equal ID. So again, we have the problem here. It's supposed to be a string, so we change it to string. Just going back to the controller, remove it as a number. And it also expects me to pass data for the update operation. Now it's not complaining here anymore, which is fine. And the reason why is actually update product DTO is actually a partial type. So it's actually extending all types or properties from create product, but just sets them optional, because then we can easily create the endpoint for patch. We can just refresh here. And as you can see here, all those types in comparison are optional. So during an update or a patch, we can just update one or two fields as we want to. We can try out some of the update functions. So let's have a look. Maybe we'll just use any product here. I'll take the ID of the product, enter it into here, and then replace the body. The body will be, for example, standard pedal new stickers. So I will execute it and I get a result. So now the name has changed, but the price and the SKU of the first product is still the same. And of course, I can also change the name and the price and always get a response back. And one more thing. So we are just changing also the published to false. And here it is. Nice. Next is the delete endpoint. So we're just going to use Prisma again, product and delete. One last time where ID, set the ID, we have to change it to string. And that's it for delete. So I can just copy this product ID here, use it for delete, and see if we can actually delete a product. And it says yes. To just make sure it's actually deleted, we can open Prisma npx Prisma Studio again. And as we can see, we have still 15 products. We have added one product in this lesson, and we have deleted one. Nice. All right. Final task for this part of this lesson is to create a new endpoint, because right now we only implemented existing endpoints, which has been generated by the CLI resource command. And we just want to create a new get endpoint to fetch all unpublished products. So we're going into the products controller and create a new endpoint. We're doing this above ID. So we can say drafts, for example, find drafts. And then we return also the products service, find drafts. We're going to implement this function. I can jump into it. And what we can actually do is we can just copy, in this case, the same function for find all and just change the filter to false. And now if I go back, refresh Swagger API, I have a new endpoint. Run it, and you can see all products which have published value false. Perfect. So yeah, I think we are taking a break here. So you will do the task now on your own. And we will see each other back in 5 to 10 minutes. And then we will also add Swagger types to the response and have some additional transformation and validation coming up. So just shoot a comment into the chat again when you're ready with the first CRUD operations. All right, the minute is over. I will continue with the next part of this lesson, and this is Swagger types. So currently we are just returning the plain JSON object retrieved by the Prisma client, and that's totally fine. But Swagger cannot automatically define the response types for the product model. As we can see here, there are no schema definitions. So the first part of this task is to create a product entity and make also the properties visible for Swagger. And again, using API property decorator. And we can just go into the products directory, and there's an entity folder. And I'm just going to change this to product entity. And the reason why is we can maybe at the beginning of early prototyping of your REST endpoints, maybe you want to keep your entities in sync with the Prisma model. And so we can even inherit all properties from the Prisma client. So what I will do is I will implement the product type, which comes from Prisma, which has been generated. So I can just implement everything. Here we have a new import, which is decimal. So we'll just change that to Prisma instead. So importing Prisma and changing it to Prisma.decimal. All right. So basically at the beginning, if we want to just return the plain object, we don't want to change anything or hide anything in this model, maybe it's fine, but maybe in a, for example, user model, if we want to hide, for example, passport field, this might be possible, is still possible, but you just have to consider if you want to expose all of your data or just a subset. But yeah, at the beginning, it will be fine to just expose it. So right now we are still missing the API property. So I will just add them the direct decorator to each property. And copying just a few in between. And I shouldn't have added the semicolon here. Now I have to remove it everywhere. Sorry for that. Now we have the properties and the API property ready. What we also want to do is mark values again, for example, the description as not required and even nullable. So we can say false, and we can also specify nullable to true. And we could do the same for published, but not required or nullable. We can use the default value. So we can say here, default is not true, it's false. And here for the Prisma decimal value, as we can see here, the price is actually returned as a string. So we can go into the property. Oh, wait, I will just show you. No, it's not applied yet. So actually before I want to apply it, and I also want to change this type to string. To do so, we are going to use actually an annotation for Swagger to pick up the response type. And to do so, we can use API OK response, for example, for get and delete, and the API create response for post and patch, and define the type of product entity. So going into the controller, I will do it for example, here, API OK response, so returning 200 status code and specifying the type product entity. Because product entity is returning an array, we have to wrap it into the brackets to specify it's an array. Or we can also say is array to true. And then if we refresh, we now have our schema in place. Schema validation, we have an array here, our object, but price has an object. We can go down here, and this is because it's currently set to decimal. This is what Swagger is trying to generate from the type decimal. So we just changed, as I said before, to type string, refresh here, and now it's actually a string. And here is the definition, ID, and everything marked and already. All right, so this is the first task. Just to point out, actually, because we're adding a bit of boilerplate right now, this is the API property. There is a Swagger CLI plugin provided by Nest, which you can enable in the Nest CLI JSON to actually automatically infer the type for Swagger based on the TypeScript definitions. So for example, this is what we are currently using, and this is what we could use if we enable the CLI plugin. I can just scroll down. This is how you enable it. You would add this to this Nest CLI. I'm just sticking to this way just to show how to do it, and this will actually help you later to just remove some extra boilerplate. Nice. Right, so next we want to validate some incoming requests. So for example, what happens if we create a new product with name empty and SKU empty? Will that work? We can actually try it out and post this to the post products endpoint. So try out, run it, and it was successful. So it actually added this new product. So we can also see it in the Prisma Studio. And here we have it. Name is empty, description is null because it's okay, and SKU is also empty string. Nest has a built-in validation pipe we can use to actually validate incoming requests to the API. And this uses class validator package. Class validator has been added to the dependencies because it's used for Swagger. So now we want to use the validation at the application level to protect all endpoints from receiving invalid data. So we're going into the main TS. This is the application level. We can say app, and we can use a global pipe because it's a validation pipe. And we say new validation pipe. This is the first step. And then nothing changed yet. If I would do the same request again, it will still go through. But we can add some decorators to actually apply validation rules to the create product DTO using decorators of the class validator package. So for example, here are the validator decorators. So for example, there's an validation is empty, is array, is init, is int, and there are lots more we can use. And I defined a few rules we want to apply to the create product DTO. And so we're just going into the DTO. So let's first add a validation rule to the name. It should not be empty. And we can say is not empty. That's really easy. And then we also want a minimum length, for example, of 3 characters, min length 3. We want to have the description optional, is optional. And we also want it of a maximum length of 150. So max length 150. So is optional, as it says here, checks if values is missing, and if so, ignores all validators. So if the description is optional and empty, it won't check if it's a maximum length of 150. The price, we want to min of 1.0. And all of those decorators are coming from the class validator package. And again, for the skew, we want it's not empty. And we also want a min length of 5. All right, so if we execute this again, now we don't see it added to the database because before it's actually hitting the API, Nest will validate our request and tells us what is wrong and which validation rules have been broken. And for example, name must be longer than 3 and shouldn't be empty. So if I change this to stickers again, and maybe some product SKU stickers, and execute it again, only one message is left. So the price must not be less than 1. And then if I change it to, for example, 10, I can execute it again, and it's actually added to the database. So refresh, and here we go. We have the product added and validated. All right. Cool. So one more thing, maybe you noticed as I was talking about the price, and the price is actually a string, but we defined it as a decimal. So maybe it would be nice to actually return it as a number. So we can also use a built-in interceptor from Nest to add it to the application level, which will use the class transformer package, which also have been added to this project because of Swagger. And we can use it a little bit like validation pipe to apply transform rules for our responses. So we're going into the main TS, and we say app.use interceptors, new class serialization, and the serialization needs a reflector, so we can get this reflector class from app.reflector. Here we go. And now we also want to apply some serialization rules, in this case to the property. And now we want to apply transform to the price. I'm just going to add a constructor here just to show you, if I say price, I can actually use all of the functions available by the decimal type. And I have actually a function which is called toNumber. So, and in the end, it's actually a number which is returned. So we can apply this by adding the transform decorator. Just need to make sure to import the correct from the correct package, and it's coming from class transformer. Here we can get the value, and then as we saw it here in the constructor, we can say value.toNumber. And then, of course, we want to change the type not to be string anymore. We want to have it as a number type. All right. One more step is required for the transform to be actually applied. We need to actually return an instance for the product entity instead of just the plain JavaScript object. And we also have to assign all these values to the class. So we can add a partial here, partial and type of product entity, and object assign. This is just a quick way to assign all values to this to this class. Partial. I just want to show you what I mean by that. Otherwise, this would be needed to assign all values for the single property of this class. Nice. So as I said, we also need to create an instance. So we're going into the controller, and for each class, for each endpoint, we need to now return the instance of a product entity. So I will show it for find one. I will change it to asynchronous, so I can actually await the Prisma client to return the property. And I will do that here. And now I will say new product entity. And I will close all this. And then if I refresh here and go into products, I need to fetch first an ID for me. I will enter it here. And we see it doesn't show the price anymore. One moment. I also have to add this for the actually schema. And I just want to have a look one more time. What happened to the price? Oh, I'm not calling actually the function. I'm just saying to number. So if I run it again, now perfect, we have the price as a number. Awesome. So basically I didn't apply all the responses yet. So, okay, API created response. I will just add it now. For the type definitions, type product entity, product entity. Copy this for the update function as well. And then I can also copy this one for delete because it's returning an OK and the product entity. And we can copy this one as well for the draft. All right, just one more time refreshing here. All of them should have a schema now, and the price should be a number. And if I fetch now products, as we haven't applied all the instances yet, we still have to do that. So I'm going to change that quickly as well, asynchronous. I'm going to save a products const right now, awaiting all the response, and then returning products. And I'm mapping the products one by one into a new product entity. So the transform can actually be applied to the response product. All right, and I can just copy this one for the draft as well. We are just awaiting const drafts. Wait, asynchronous, and changing this to drafts. We have to do this also for create. Wait, new entity, product entity. And two more steps for update and remove as well. Async new product entity, await. And last but not least, we do it for remove as well, product entity. We want to await it here as well, so asynchronous, awaiting the value. Done. So we can try it out again for the find all products, for example. And as you can see, it changed from string to number now. So it's applying the transformation for the responses. So what did we do? Added Swagger types for the response, validated incoming requests using validation pipe from Nest.js, and also transformed price from a string to a number. There are more transformations available if you want, for example, excluding properties like the password and maybe renaming this is all possible using the transformation or serialization option. All right, so now you have, again, 5 to 10 minutes to complete the task. And I will be answering your questions. I see a few, and we'll get to back to them in a minute. All right. Yeah, I answered a few questions in the Q&A section. I just wrote them down because they're a bit not as easy to answer, I guess. It was about DTO and entity, as Jakob just wrote down in the chat again. I couldn't find any definitions or guidelines on Nest when searching quickly for that. But I tried to use DTOs as a request object for like the body or maybe a query parameter, and an entity for the response. And maybe an entity is also something which represents an actual entity from your database. So as an example, you might return a DTO for pagination, for example. The page information will be the DTO, just providing some additional data around an entity, for example, page of products. Then you have a page DTO and an entity product. Yes, this is basically just naming scheming, I guess. I think this is a good way to remember DTO for requests most of the times, and an entity as a response. Good question. All right, it has been 10 minutes now. Are you done with the tasks? Just drop a comment into the chat. Awesome. One is done. I think I'm just going to open the next lesson already, and then maybe waiting 1 more minute. Joshua is ready as well. TJ is ready. So I'm just going to start. I think we're a little bit behind the schedule, but anyways, I hope you can follow along later otherwise. So the next lesson is about error handling. Sometimes there is an unexpected error and an exception happening, and Nest has actually a built-in exception filter which just throws a 500 internal server error if there's an exception and doesn't know how to handle it. And Prisma Client also introduces some new exceptions, such as Prisma Client noun request error. And we can use this to, for example, catch unique constraint validations. And we are going to implement a exception filter and add it to the base application level, and filter out any errors coming from Prisma Client, at least the known errors. To do this again, we have to switch again our branch just quickly, just to make sure. You can also stay on your branch, but just to make sure everyone has the same state. Git checkout REST API complete. So as you can see, I have everything in place as well here. I'm just going to start and run start the dev server again. Right now, we just want to try out and execute the post command, the post endpoint twice and see what will happen. I'm going to copy, oh, this is not what I want. Copy the payload and try it out, execute. And for the first time, it actually works. If I refresh here, it should have added the new product, stand-up paddle sticker packs. And if I tried the second time, we are actually getting a 500 error internal server error. And also in the terminal for the Nest application, you can see there's an error thrown by Prisma Client. And it says, because of a unique constraint failed for this field. And this is the expected error because Nest doesn't know about how to handle it. So it just throws 500 anyways. And this is because of the global exception filter. So now we are just going to create an own exception filter for Prisma Client. We can again use the CLI to generate one for us. Going to do that right now. Going to open it. And so we have to do two things. First, we want to actually just catch the Prisma Client known request errors. So we can use this name. We import it again from Prisma. Prisma is the namespace and exports a few things like this error as well. And we can use it here as the type as well. We are going to remove the type here. And because we want to, if we don't handle all exceptions from Prisma Client, we maybe want to fall back to the base exception, which is 500 internal error. So we have to change the exception filter to the base exception filter. The base exception filter just throws an 500 error if it doesn't know how to handle it. So I'm changing it. I'm extending the base exception filter here. We can remove the exception filter right now, and we just call super and pass to catch the exception and the host. All right, so if I go back, I have to start the server again. So if I go back here and run the command, nothing changed. We still have a 500 error, but it just works. So just to make sure the 500 error is still thrown, but actually it's not yet applied to the global application level. So it doesn't even matter right now, but we can, yeah, assume hopefully this will work. Right now, we want to next catch the error code. So we can go onto Prisma docs to actually see if which error code is returned. So for example, exception.code, we want to know which code is thrown for a unique constraint error. And we can go onto the Prisma docs right here. And there is the error code P2002. And this is for unique constraint failed. So what we can do is we can catch the error code and return, instead of a 500 error, a conflict, and maybe returning the exception message as well. So we can do a switch for the exception and the code. And then we are going to have a case P2002, I think. And we are going to break here. And for the default, we just want to return the 500 error. So I'm moving the super catch into the default break. So I just want to now change the response. I can get the response by using the host, and we can save the context, host.get switch to HTTP. So this is the argument host, and we can have a response context.get response, and we are going to say it's from type response, and we want to import it from Express. So in the switch case for the P2002 error, we can now say response, and we can change the status to HTTP status and change it to conflict. And we can also provide a JSON object as a response as well. So we can say, as we want to say, it's a status code of 2409. So status code, and we can here use again HTTP status and conflict, and also providing a message here. And the Prisma exception has client version code message and some other information. So we are going to use exception.message to be returned for the unique constraint validation. Now we just want to apply, and again, we want to do this at the application level. So we open main.ts, and we have to do a little extra step here. So first, I'm going to apply the filter. So app.use filter, global filters, and then I say new Prisma Client exception filter. And here, because we are extending base exception filter, we will have to pass an instance of HTTP adapter host. If it would be just the exception filter, what it was before, then we don't have to do that. But otherwise, the base exception filter doesn't know about the response. So we can say const HTTP adapter here and get it from app.get. And then we say HTTP adapter host. And I wrote it wrong, so HTTP adapter. And then I can pass this into the instance for the Prisma Client exception filter. Saving it, it rebuilds, and then we can try it again to post the same product, and we are seeing a 409. So this works. We are getting a new error code 409. We also have a new message. Status code is in here and the message as well. I see a few line breaks in here, so maybe we want to clean them up. So we can just go in here and say replace, and there are a couple of them. So maybe regex would be good here. So global, and remove all line breaks with nothing, like a blank. And then we run it again, and now we have a quite nice looking response message. We can even add, if we like, anything else what might be useful, maybe the client version from Prisma, and maybe some metadata, anything we like to pass in here. And this is basically it for this lesson, but I just want to remind you, this might be a good place to add additional error codes. For example, if you try to update or delete a record which is not available, Prisma will throw an error. And also maybe if you limit your columns to a certain size, you might get a value too long for this column error. And you can find all of those here on this exception page for Prisma docs. And if we scroll down, so for example, not found would be P2025. Yeah, so this is error handling for Prisma client errors. So you have, again, 5 to 10 minutes time to implement it on your own. If you have any questions, just again, shoot me a question in the Q&A section, and we will get ready for the next lesson in 5 to 10 minutes, and it's pagination. I just want to answer Garrett's question if the Prisma specific error codes are in enum. I'm looking right now into the type definition for Prisma Client known request errors. And unfortunately, right now, the code is a string. So you have to actually look up the error codes on the documentation. The other way would be to maybe create a issue, like a feature request at Prisma GitHub repo. And maybe they will add an enum here in place of the code, which might be actually useful to select and implement many of the known errors. I think we can move on to the next lesson, and I need to look onto the time, already 7 o'clock. Moving into here. I will answer the another question after I've done this. I've shown you the pagination part. This takes a bit more time for the types, and then I will get back to your answer, Drew, your question. All right, pagination. Pagination is quite useful if your database is growing, your product records are growing in size, and you only want to return a limited set of products. And Prisma offers two different methods for pagination. One is the offset pagination, and the other one is cursor-based pagination. And you can have a look at the documentation for Prisma for the difference. One difference for the offset, you can always jump to a specific page, but it doesn't scale for a huge amount of records. So it's recommended to use offset pagination, for example, for posts of a blog. And cursor-based pagination uses also the offset, the take first and skip, but also uses a cursor to jump after this value, and you cannot guess and you cannot know where a page starts and ends. So you basically have to start somewhere and then navigate from this cursor to the next, and so on and so on. But this scales. There are no issues with larger data sets, and this is usually used for infinite scroll, for example. And we are going to implement the cursor-based pagination, and we are going to use this small package here, Prisma Relay Cursor Connection, and we are going to create type-safe requests and responses for the Swagger API. Just having a quick look here, this Relay Cursor Connection basically extends Prisma Find Many for any model, and for now we are just using it for product. And it adds a validation for the connection arguments. And those arguments are first and after, so forward navigation, and last and before, backward navigation. And it also has a page response, and we are going to use this soon. So right now, we just have to switch again to the other branch. Just git stash and check out error handling complete. All right. So this is here. And right now, we can just add this package. So basically install this package. Here again, the connection arguments are printed here. And also I can show you quickly the page response, which types they will have. So the global response will be a connection, which has a address array, page info, and total count. Page info just tells you if there's a next page or previous page, and then the cursor you can use to change the page. forward or backward. And then one edge is basically a cursor and the node itself. So we want to implement a new endpoint in the products controller. And I'm going to drop it in below find all. So get page, products page, and then I will say async probably find page. And then I return this from product service again, find page. It's not there yet, so we are going to create it. Just basically implementing the new CRUD operation. All right. This is basically what we want to do for the get products page endpoint. And now we can extend find many with the find many cursor connection. And we also have to connect it with count. So basically we are just returning this new function. We will have to import it, import from the correct package from evoxa Prisma relay cursor connection. That's fine. And it requires us to, first of all, get arguments. So these are the connection arguments we will receive. And I'm going to create an object, a function, callback function here, and I'm returning the find many for products here. So Prisma product find many and find many, and I'm passing the arguments to find many here. And we also need to specify an aggregate function. So this will be just returning the count function for products count. And the last thing is the connection arguments actually for pagination. So if I pass here empty connection arguments, we can have a look again. It should return all records for us right now. So we are going to start the server in dev mode again. Just refresh Swagger API after it's available. And we have a new endpoint, the page endpoint. So if I execute it, I'm getting a new response, and the response is the node or the edges inside our nodes and the cursor. And at the bottom, we have a page info. And because we are retrieving all informations or all pages or all records, we don't have a next page and we don't have a further page or previous page. And the total count is 18. We can check. I think the Prisma Studio is still running. And yes, we have 18 products. So we have connected find many cursor connection with find many and count of products. And probably we just want to filter again for published products here. So what we have to do is we have to filter find many. I'm going to add a where clause here, and I'm spreading all the arguments in here. So we are using them anyways. And I'm adding a where clause. And actually we can use and create a where clause outside here. I will show you why. And we can say Prisma product, just import the namespace Prisma again, product where input, and we can say published true. So this is basically the same as defining it here directly. So what happens now if I execute? We only have the true values, so all published products. If I execute, we are only getting the products with true, but the total count is still 18. So that means we also have to apply this filter to the count. So always keep it the same. Right, so if I execute it again, boom, we have only 11 as a total count because the other 7 products are not published yet. Nice. And we can also have a look what happens with the arguments we are passing. So we're just logging the arguments right now. And they will be empty because we are not passing any values here. I just want to show you what actually happens with find many cursor connection. So just going to the documentation right now. And we are also supplying take and skip probably, but we are not using those names. We are using first. So for example, the first 10, if I provide first 10 and execute it again, we have as next page is true. So we have an additional page, and now we only return 10 pages. 10 records for this page. And what actually happens is find many cursor connection takes the 10, adds one to get one more record from the database and verifies if there's one more and tells you, yes, there is an additional page available. But it's actually just returning 10 as we ask for. And if we change this to last and execute it again, it just adds the one value again, but turns it around, adds a minus for it, and this is then backward navigation. And as we can see, has previous page changed to true, and next page is false. All right, this is the connection. So we actually want to, in the next step, add the connection arguments as a query parameter. To do so, we are going to create a connection args DTO in this case, and we are going to create a new page directory to just place all page-related files in here. So we're going to create connection args.dto ts export class DTO. And there are 4 values. So the first 2 are first number and last is a number. And then we have after, it's a string, and we have also before as a string. We also want to make them again visible for Swagger, of course. So API property. And as they are not required, we are just setting it to false. And I'm just applying that for all of my properties here. And we can go into the products controller. And as you can see here, we are applying, for example, for the create endpoint for the post, a body. But in our case, for the page, we don't want to have a body. We want to have a query parameter. So we can use the query decorator and pass here the connection args. And that's of type connection args DTO. We just pass this to the page function and service, also connection args DTO, and we can apply, so we remove the empty connection arguments with the query arguments. So now we can actually try and try out what happens in Swagger. So now we have our types here, and we can try. So first, let's try empty parameters to, again, return all parameters or all records. And it works, as we can see here. And then we are supposed to try to return the first 10, as we did earlier. So we try to say 10 first. As you can see here, we are unfortunately getting one error. And this error is because query parameters are always received by Nest as a string. So what you can see actually here, the parameters receives 10 as a string, adds 1, so it's not 11, it's 101, and Prisma can't use a string as a take operator. So what we have to do is we actually have to transform incoming requests to a number in this case. And to do so, we can actually reuse the validation pipe we used in lesson 2. So if we go into the main TS again, we have our validation pipe here. And what we can do is we can automatically transform. So we can add an option here, and there's a transform option. We can say true. This is not enough for the arguments. It will be enough for for parameters, for example, on these parameters. If I wanted to have this as a number, I could just write number and it will transform them automatically. But for query, it's not enough. We can have an additional option, and we can enable implicit conversions based on the type. So basically, because we're saying this is a number, we can or Nest can now transform it to actually a number. So if I go back and try to execute it again, now it's not 101 anymore, and it's 11 and is a number. As you can see here, we have a valid response. Cool. One thing you should notice, we have first and last as a number. And Swagger doesn't allow us to, for example, add a hello to the parameter because it knows it's a number, but we can actually call this endpoint via the endpoint definition. And if I actually add a string here as a first value or even as a last, I'm still getting an 500 error because this value cannot be passed to a number. So what we can do is we can use the transform class transformer, class transformer again to transform this value actually to a number. So we can say is number. And because it's optional, we also apply is optional. So I'm going to copy both of them to the last value as well. So that means if it's optional, if it's not available, don't check is number. But if it's available, check if it's a number and return otherwise a different error. So if I refresh this page now, still get an error, no 500 error anymore. It's telling me it must be a number. And here, if I enter 10, because I can't enter any strings here, it still works. All right. One more thing. This is a bit more, and it's the response type for Swagger. Right now, it's just returning again the objects, and we don't have any schema for this, like we do, for example, for the find all products here. To do so, we are going to create a couple of DTO files, and we are doing this with a generic. And the first class we're going to create, I'm starting with the page.dto.ts, export class page, and we call here record. So this name can be anything. It can be T, it can be, whatever you like. So right now we need the total count as a response type, and this is a number. We need a page info object, page info DTO, or just page info. And I'm going to page info DTO, yes, export class page info. And as I wrote down here, the page info has next page property, Boolean, has previous, I'm just copying it over, Boolean. It has also a start cursor, which is a string, and an end cursor, which is also a string. All right. And we have to, of course, import it here. And last step is to add the edge DTO and edge DTO TS has two properties. Edge. We need generics again here. Copped. And so this will return the node, which is the actual, for in our case, the product, and the cursor as well. Cursor is a string. And now we can add the edges, edge as an array here. And we pass the record as well. And I have to import it from the DTO file. All right, so again, Swagger needs some help. We are applying an API decorator, add API property. And I'm going to do this as well in the page info object. For all the fields, I have to import the class. All right. There's one problem though, because Swagger can't handle generics, because at the time, at runtime, it doesn't have this information about the generics anymore. There is a way we can actually use raw definitions by NestJS and defining certain properties using, allowing us to specify the actual schema for us. So I'm just going to actually copy this out because I think we are a little bit short and I can explain it better, I think. So as we have API created or API OK response here, we are also having an API OK response here, but we are providing the actual schema here. And we're starting with a combination of the page DTO. So I'm importing the page. I also need to import the get schema path. And what we are going to do in the next step is actually to tell Swagger how the edges will look like. Edges is a type of array. It has items, which is an object. We have required values or properties in this object. These are cursor and node. And those properties are cursor, which is of type string, and the node is the type object, and again gets a schema path. And this is the product entity. Sorry that it's just a quick one here. I can show you. Yeah, so we getting a small error right now. This is because product entity is known by Swagger, but it doesn't know page yet. So there is a way we can add a API extra model in here. So Swagger is aware of the page DTO. And if we refresh again here, now we have our Swagger types in place. One more thing, we like maybe to reuse this decorator here. So what we can do is actually create our own. So instead of having API OK response and always passing this long schema here, we can actually create a class. So we call it API page response. We create API response page response TS here. And what we can do is we can actually create our own decorator, and the decorator will receive the OK API response we used before, but we can pass the actual model into this schema. So I just copied it over here. As you can see here, I just have to import a few types. Apply decorator and API OK response. We want to get the schema again from the page DTO, because this will always be the same. And then we can pass here the model actually. And these are two additional fields actually, because we can actually create a naming for the responses. So just to check here, schema, we don't have a name here. And also for the edge, there's no name. So if I have a look here, this is actually product entity. Just the name is missing right now for, for the schema. And how to apply? We can just use the name API page response, go back and remove this long OK API response, add API page response, and pass here the product entity. All right, and when I refresh, I need to open page again, and we still have the same type in place. And if I look, we now have the naming in place as well, which comes from this one, the title page response of, and then the name product entity, and then the same for the edges. All right, I think there is one more thing. Noticed that the price is a string again. We applied transformation before for our other endpoints, where we created an actual instance of product entity. So we have to unfortunately do it here again. The find many cursor connection allows us to pass an additional value here, record to edge, so we can actually match our node value here. And we have to basically return a new instance, new product entity, and we're passing the node in here. So one moment. Oh, I have to wrap it in curly brackets. Oh, okay, sorry. So it's actually getting the whole record, and then I have to pass and tell only what the node will look like. And we could even add some additional information here if we wanted to, but we're just going to use the record as the product entity. Record, yeah. And one more step, because this won't be enough. We can just check. We are returning an instance for product entity, but because we are returning find many cursor connection as the return value, we also have to create an instance for the page as well. So what we can do is basically say const, and we await the value here, page, and await, and then we return a new page from type product entity, and then we pass the page. I think we still have to import it, yes. And there's no constructor yet, so we have to pass the constructor partial type of page. And also providing here the generics. and assigning it again, like we did in the product entity. Assign is partial. And because the transformation is still in place, we don't have to do anything else. I just need to see what happened now. Oh yeah, so I forgot to mark some informations. That's why I'm getting a type error here right now. So the page information start cursor and end cursor can be optional. So we have to actually say they can be nullable or optional. Otherwise, we cannot build because of the type inference. I added one S too many. Let's refresh again on the page and execute. And now we have also our price again in number. And we can try to do a forward pagination. So what we would do is we go in here, say we want to get the first 10 values. I execute it, and then I can scroll down. Yes, I have a next page. I take the end cursor and tell the query param, go after this cursor and show me the next 10 pages. And as you can see, we only have one more record, one more product in here, the super sticker packs. And as you can see here, this is the connection arguments which have changed. It contains now the cursor ID, take is the same, and it skips the actual cursor. Otherwise, the previous last cursor would be returned as well. And we can change this up. So for example, doing backward pagination with 5 products per page, we're going in here, 5, execute. That's not what we wanted. 5 is not supposed to be in the string. We want to have it in last. So we haven't catched any errors yet here, but this is just to showcase and implement the first things. And now we are grabbing the start cursor, using it as before. And as we can see, we still have a next page and a previous page, and we can continue using a new start cursor until we don't have a previous page anymore. All right, this has taken a bit longer, so you can take your time now, and I will be back soon. I will see if we can do a little bit more because there's one more lesson left, the authentication. All right, I'm back a bit earlier right now. Just a heads up for me and for you, we have 25 minutes to go because there are going to be some more workshops. So if you don't mind, maybe I will just finish the next lesson, the authentication, and you can get back to the pagination and also practice the authentication as well. Sorry, I think it took a bit more time at the beginning, so I will just do that right now. I hope that's fine if I show it right now, and then you can do it later again on your own. I don't want to miss out on the authentication, which is quite useful as well. So the last lesson basically is authentication, and we want to protect our endpoints. Right now, all of the endpoints are unprotected. And the goal of this lesson is basically to implement JSON web token authentication. And there's a package which is called Passport JWT, which will help us to implement this. So what I will going to do is again change my my branch. You always have a node for the final solution. And you can also, if you have some problems, you can either look into solutions branch or in the solutions in the Notion document. So I will stash my changes and I will check out pagination complete. All right, Passport. To actually get Passport up and running, we are going to need a few dependencies. We are going to need nest.js Passport and the JBT package. So I'm going to install that here. And also there's a dev dependency for the Passport JBT package as well. I'm going to install it as well. All right, I just added a new model and we are going to copy it over to the Prisma schema. We can add it above, we can add it below, and we can just execute a new migration, execute npx prisma migrate dev, and again, add a name, for example, user. Change the product table unique. Okay. There are some changes, so I can say yes. It looks like we are losing our SQLite database data here, but because we are doing a dev migration and it picks up my seed.ts file, it will automatically seed the database, and actually it receives an error. Let's quickly have a look. This is, so I'm just removing the DB right now, just to test out one more time, just to see if I messed up something. Migrate. Now that's fine. And then I will try to run the seed, DB, seed preview feature, running seeds. And this works. All right. Not really sure what got wrong there, but anyways, I think the studio is still running, so we can actually have a look. And we can see, we don't see, maybe we have to restart Prisma Studio as well. And yes, we have a new table or new model, user model. And I wrote for the setup, we are going to add a new example user. We calling him Bob. Bob has an email, bob@shop.com, and the password will be Prisma Day 2021. Just a disclaimer: never store passwords in clear text. Use libraries like bcrypt to store passport hashes. But for simplicity, I'm just storing it right now as a clear text. All right, so what we want to do now is we just want to generate a login, or we want to have a login method to actually receive a JVT token. And to do that, we're going to generate an auth resource using the nest generate resource command again. This time we are saying auth REST API, and we're saying no to CRUD operations because we only want to implement one new endpoint. Opening auth controller. And directly, first thing we want to do is we add the API tags auth to the controller, just to group the calls together. What we want to do now is we actually want to configure the passport modules. So there are actually two of them, and we are going to add them to the auth module. So what we are going to do is we are going to import them here, passport module, and we have the JVT module as well. and we can say register, because JWT module requires us to provide a secret key, which is used to sign your JWT token. So we can pass a secret here. And as we are going to need it again for validation, I'm just exporting it here, but it would be much better to move it into a .env file as written here, and also using the nest.js config module to actually load it from an environment file. JWT secret Prisma day 2021, for example. And we can also pass an expire option, and this is sign options, and it should expire in, and you can pass any time, for example, 60 seconds or 60 days or D for days, and I'm just going to say 60 seconds right now. Maybe depends on your use cases here, but it says here 2 days, 10 hours. Yeah, what you like to specify here. This is for configuring Passport. It's quite easy. And what we can do now is we can implement our post login endpoint. So we're going to go in here, say post, call it login. Async login probably. And for the login, we want to have a login DTO, so input again, and the DTO should be the email and passport to authenticate a user. So I'm going to create a DTO directory, login DTO.ts, export class login DTO. I'm just copying it right now because it's a bit faster, but I think you should be familiar with the most things we are using here right now. API property again for Swagger, and validation is email and is not empty. And then we can actually use it here as a body. And maybe I want to deconstruct login DTO and use it as email passport, for example. And then I'm just returning a login from auth service. Oops. Well, now I clicked too many things. Login, and we're passing the email and passport, creating a new function. So we want to validate if this email actually exists. So we're going to use Prisma to actually see if the user is available. Prisma service. I don't need the Prisma client. So we can actually start by injecting the Prisma service and also the JWT service. So here I can also add the JWT service. JWT service is used to sign and create a JWT token for us. JWT service. So what I can do here is I can try to get the user. So I will do asynchronous calls. I'm awaiting Prisma to get back a user for me. And this should be a unique user because the email is unique. So where email. And I specified a few things here. We are supposed to throw some errors. For example, if the email is the email is not available. So if I check user is not available, then I can throw a new forbidden exception, for example. Forbidden will be 40. No, that's not correct. Forbidden, maybe not found. So 404. And then we can even paste or return some values if we like to. again, I will just copy the rest of this function just to explain it here. So what I just copied over is the last part. Here we are checking if the user password is actually the same as from before, from the request. And if it's not the same, we are throwing an unauthorized exception. And here we would also have to use bcrypt to validate the hashes and compare the passwords, as we wouldn't store the passwords in plain text. And here at the bottom, I'm actually returning an object, and the object has a property called access token, and we're passing to the access token the JWT service sign operator, and signing will use the user ID to sign. I haven't added the auth response yet, so here it is. There's an auth response. So I'm just going to create this auth response as well. So entity auth, entity TS, and export class auth. And this has the access token string API property. Here we go. If we go back to here, we have to import the auth entity, and it seems to be fine. We can run npm run start dev. And we can try already our endpoint. So if I refresh here, I should have a new endpoint, the login endpoint. And if I say Bob email address, shop.com, and provide the password, Prisma Day 2021, and execute it, we are actually getting an unauthorized exception right now. And this is because I wrote Prisma wrong. And here we go. We have our access token, and the access token is can be used to authenticate for our endpoints. I'm just looking at the time, so I think it might be better for me to just unfortunately skip the last part and just change to the finished solution, and then I can just talk about it. Git stash dot git stash, and then I will just change git checkout. And I just want to show you on the Swagger API what will be different and what we also added here. So I would need to add a JWT strategy. The strategy would implement to actually get the validation object from the token and tries to use the user ID to validate it. And we have to also provide the JWT strategy here. And also there's a JWT guard we use for securing our endpoints. So for example, create has a use guard, and this is applied here. So if I go into the Swagger API, we are actually even seeing the logs here, because there's a property API barrier auth added to these secure endpoints. And if I try to run one, we can see 10401 error unauthorized. If I go and log in quickly again, Prisma Day 2021. This time it's correct. Now I have my token. I can use this token to add it to the authorization And now I can actually, for example, get all our drafts, and I don't have any unauthorized exception here. If I log out again and execute it again, and then I have 401 again. Sorry for the shortcut here. I'm really sorry for that. I hope this was still useful to see a little bit about the implementation for the login or authentication. Unfortunately, in 5 minutes is the next workshop. So hopefully you still enjoyed my workshop today. I hope you learned a few things about Nest.js and Prisma and both together. Also big thanks to Prisma team to planning and involving me into the Prisma day doing this workshop. I hope to see you around, probably on Twitter, GitHub, notiz.dev, or on the Prisma Slack channel. And one notice, if you're really interested in learning more about Nest.js, check out the application workshop in probably 5 minutes. The backend is based on Nest and Prisma. All right, I hope you enjoyed it and have a great Prisma day. Bye. Danke.